This is 8.4, multiplying special cases. So we're talking about two different types of special cases, what we call perfect square binomials, and also what's called a difference of squares. So works the same way as the multiplying of two binomials. X plus 2 squared is the same as, is equal to, let me recalibrate here. So this is the same as taking x plus 2 times x plus 2. That's what x plus 2 squared means. So you could either use FOIL and the distributive property, or you could use our boxes here. X plus 2 and x plus 2, so it's x squared, 2x, 2x, and 4. So notice that along the diagonal, those two terms can be combined. So you have x squared plus 4x plus 4. Now what's nice about the special cases is, yes, it does mean x minus 5 times x minus 5. You can treat it just like the binomials we've been multiplying. But it's also good to notice that when you have a perfect square, all that you have to do on that is square the first term, so take x and square it. Square the last term is the negative 5. So if I square negative 5, negative 5 squared equals 25. So I have on the end a plus 25. And then in the middle, you'll see that there's two terms, x and negative 5. If I multiply x times negative 5, I get negative 5x. And all that I'm going to do is double that to give me the middle term, which is negative 10x. And that will work every time. So it's the first term squared, the last term squared, which whether it's positive or negative will always be positive. And then multiply the two terms in parentheses. In this case, it's negative 5x, and then double that number, multiply it by 2, and that will give you the middle term. So that always works for a perfect square. Now, if you forget that, it's fine to just do it like we did before, right over here. Think of it as x plus 2 squared is the same as x plus 2 times x plus 2. Go ahead and draw out your boxes, or use FOIL. Remember, f would be x squared. O is the outer, that's 2x. The inner is also 2x. That adds up to equal 4x. And then the last terms, 2 times 2 are 4. Either way will work. Same thing with what's called the difference of squares. We have x plus 2 times x minus 2. Notice, the only difference here is the sign. So we can go ahead and just draw our box. Our rectangle, it's called a rectangular array. And go ahead and multiply. It's a multiplication table. X squared, x times negative 2 is negative 2x. 2 times x is 2x. And 2 times negative 2 is negative 4. What you will notice here when you go to combine the like terms is that they will be opposite terms. They are the additive inverses of each other, and so they will equal 0. So we have x squared minus 4 as our final answer. So one thing we can learn from this is that if I have two binomials that are the same except for those signs where my arrows are pointing, the middle term will always cancel out. The outer and inner term of FOIL will end up equaling 0 each time. So this amounts to just x squared and then minus 25, and there will be no middle term. So that's only the case when these two signs are exactly opposite signs, and otherwise the binomials are equivalent. You can count on those two middle terms canceling out. So those are special cases. Perfect square, binomial, and then also a difference of two squares when you have two factors that are equivalent but differ in signs. All right, so let's see if we can use a little bit of what we've learned here. All of these up here in problem 1 are perfect square binomials. Let's see if we can use our shortcut here. We know that the first term will be x squared. The last term will be 4 squared, or 16. So it's x squared and 4 squared. And then in the middle will be plus 2 times 4x. So my terms are x squared. Let's write it down here instead. I've got x squared plus 8x plus 16. And that's my final answer. Now x minus 1 squared, we know it's going to be equivalent to x squared. And then it'll be double the product in the middle. So minus 2 times, or plus 2 times x times negative 1 is negative 1x. And then plus negative 1 squared. When we square that negative 1, it will end up being a positive. So I have x squared. The middle term will be negative minus 2x plus 1. And that's it. This one right here, we have 2x quantity squared plus 2 times, if you multiply these two together, the 2x and the 3, you'll get 6x, and you have to double that, plus 3 squared. So my final answer is 4x squared. Remember to apply the second power to the 2 as well as the x, plus 12x plus 9. And that's my final answer. All right, in this one we have 3x quantity squared plus 2 times 3x times negative 4. If you multiply those two together, it's negative 12x. And then plus negative 4 squared. So I have 9x squared minus 24x plus 16, and that's my final answer. This board's messing up a bit here. Let's fix that. Let's get 24. All right, sum and difference of squares, which gives us a let's see here, we'll move down a little bit more. All right, so these are the ones where the middle term cancels out. If you look at the inner term, it's negative 3x. The outer term is positive 3x. Those added together equals 0. So it's just the first term, x squared, and then minus the last term squared, which is 9. X squared minus 9. This one, same thing will happen. It's going to end up being n squared minus, when you have the two different signs there, it's always going to end up being a minus there. 6 squared is 36. So it doesn't matter if, you know, what the power is. There's any binomial here. It's always going to be the first term squared. Let's write it out this time. So it's x squared squared minus 8 squared. That's what it looks like. Same thing up here. It was x squared minus 3 squared, and that's what gave me the x squared minus 9. Here it was n squared minus 6 squared. That's what gave me the n squared minus 36. So same thing here. X squared squared is x to the 4th minus 8 squared is 64. And here we have 2x squared squared minus 5 squared. Middle terms cancel out again. So this is 4x to the 4th minus 25. And that's it for special cases.